Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. Till now in our discussion on polynomials, we have discussed about remainder theorem, we have discussed about various types of polynomials, and we have learnt the long division method, right? Now during our discussion on remainder theorem, we said that when a polynomial of degree greater than or equal to 1 is divided by a linear polynomial, right, then what happens is the remainder is given by P of A. Let me remind you, we said that let us say there is a polynomial P of x and it is being divided by another polynomial, that is G of x, then you will get some quotient Q of x and some remainder, right? This is the process of division, right? And we also said that the degree of remainder is lesser than the degree of divisor, okay. Now if I take the divisor as a linear polynomial, that is x minus a, what will happen is P of x will become equal to the divisor into some quotient Q of x plus remainder. Now tell me about remainder. Will the remainder be dependent on x? Will remainder have x in it? No. Why? Because the divisor is linear. It has got a degree 1. So the remainder has to be of degree lesser than 1, which is a constant or 0, right? So I am writing r here, remainder. I am not writing r of x, I am writing r, which is a constant. Now look at it. When I am dividing a polynomial P of x, which is of degree greater than or equal to 1 by x minus a, this is the expression I get for the division, right? Now if I need to find the remainder, what will I do? If I put x equal to a, what will happen? P of a will be equal to x minus a will become a minus a into q of a plus r. Now this expression is 0, right? So this is equal to r. So P of a is remainder itself. This is remainder, right? This much we learned in remainder theorem, that when we are dividing a polynomial of degree greater than or equal to 1 by a linear polynomial, let us say x minus a, the remainder is P of a. P of a is the remainder. Okay. Now we will look at it from factor theorem perspective. I will teach you factor theorem in this particular lecture. Let us write this expression once again. P of x is equal to x minus a q of x plus r. Okay. Now tell me, if r is 0, if the remainder r or P of a is 0, what will happen to this expression? This expression will become P of x equal to x minus a q of x, right? So x minus a is a factor of the polynomial P of x. In this case, when remainder r or P of a is equal to 0, then x minus a is the factor of polynomial P of x. So if I say it other way around, that if x minus a is a factor of polynomial P of x, then remainder will be 0, right? Which means P of a will be equal to 0, right? Because P of a gives me the remainder. Now what do I mean by it? X minus a is a factor of some polynomial P of x. If it is a factor, it will completely divide the polynomial, right? It is same as asking, let us say if you divide 6 by 2, what will be the remainder? It will completely divide it, right? So the remainder will be 0. Okay, 3 will be the quotient. Okay, remainder is 0. So if you divide 6 by 2, the remainder is 0. Why? Because 2 is a factor of 6. Similarly, if x minus a is a factor of p of x, it will completely divide the polynomial p of x, hence remainder or p of a is 0. Okay, so we should learn it both ways. Now, if some of you don't understand what is the concept, let me tell you in general terms here. Let me tell you once again. Let us say if you need to check whether x minus b, let us say, is a factor of polynomial x minus b into x plus 5. Okay, you would say such a simple question. We can directly see that it is a factor of this polynomial p of x, right? But in cases where you directly cannot see, for example, if I give this polynomial p of x as x square minus bx plus 5x minus 5b, that is x square plus 5 minus b x minus 5b. Now if the question is, you need to check whether x minus b is a factor of this polynomial, how would you check it? Right? You cannot directly see that x minus b is a factor of this polynomial. So if it is a factor, whether we can directly see it or not, right? If it is a factor of this polynomial and I put x equal to b, okay, then this factor will make the entire expression 0. Okay, whether this expression is written in this form or in this form, it doesn't make a difference, right? If I put x equal to b here, what happens is p of b is equal to b square plus 5 minus b into b minus 5b. Okay, so it will become b square plus 5b minus b square minus 5b. Now these can be cancelled and these will also be cancelled, so it is equal to 0. So p of b equals 0 means x minus b is a factor. I hope you understand it both ways. If x minus b is a factor, that means if I place x equal to b in that particular factor will become 0, hence the entire expression will become 0, right? And if by putting x equal to b the entire expression becomes 0, then x minus b is a factor.